So I'd like to invite Steve Francia to join me on stage. Steve works at MongoDB. How does that look?
All right. Am I mic'd? Yep. Yes? All right.
Yep.
Wow, this is a great crowd. Look at this crowd.
Yeah.
You know what? Before we start, I just want to say this is an amazing community, and it's great to see all these faces. And thank you all for coming, and I hope you find what we're about to present valuable. So we're going to talk about MongoDB, Go, and Mango. And before we start into that, I just want to talk a little bit. My role at MongoDB is it's a pretty unique role. I'm responsible for integrations with all the programming languages. We support internally over a dozen, and it's given me a really unique vantage point of how to work, how the different languages work and the interactions, how the different communities work. And one thing it's really taught me is given me a profound and deep appreciation of Go and this community that we have here. One thing that's common through all of these languages is there's a need to persist structured data. And not only to persist it, but to be able to take the structured data and retrieve it back into that same, take the persisted data and retrieve it back into the same structure that we had originally. And so I want to talk about one solution to do that, which is called BSON. BSON is inspired by JSON, but it's a binary format. It has rich support for types, and unlike JSON, it's optimized for scanning. So you can have deeply nested structures, and it will optimize for finding only the values nested without having to traverse the entire tree. So I want to do a little demo with serialization within BSON. So we have a regular Go struct here, a person. You'll notice we have a birthday with an actual date type, which is something that doesn't work well in a lot of other serialization formats like JSON. And so we're going to marshal it, this struct, into byte slice, and then we're going to take the byte slice and unmarshal it into a new struct. And we'll run the code, and you can see that the transformation is it works both ways. So I want to talk now about MongoDB. So a lot of people have heard of MongoDB. Maybe some of you used it. We know it's one thing we commonly hear is a document database. But MongoDB is actually a document database for BSON documents. And BSON documents in our world is really equivalent to a Go struct. So when you think about it, MongoDB is actually a database for Go structs.
Right, and you can actually disable. A lot of people think about MongoDB as a JavaScript database because when you log into the shell, the first thing you get is a JavaScript environment. But it's really not. It's implemented in C++, and you can even disable JavaScript entirely.
Right. And so for us, the way we interact with MongoDB from Go is through the Mango driver, which Gustavo is the primary author of.
So the story behind Mango was I started writing in Go more seriously around the mid-2010, and around that time I started wondering, where do I put my data, right? There were not a lot of options by then. The language was released in the end of 2009, so it were just a few months in the wild. And the first thing I did was, as we do, is to try to implement my own thing. I started to create a small memory-mapped database. But so at Canonical, I worked I created the ORM layer that is used both by Launchpad and by Landscape and by Ubuntu One as well. I created that layer that communicates with Postgres, and it can also communicate with MySQL and SQLite and so on. And although I like it, it was an extra layer, and I really did not want to do that. I wanted to have, first-class objects. So instead of my wannabe database was going to be something that could store those values directly into the database. And although that was doable, and it still is, there's a lot of nice people working on that, as we have seen yesterday in the talks. Writing a database with a complete feature set takes a lot of time, right? And I really I didn't want to spend my time just doing that. I wanted just to unlock other applications that I wanted to invest in. So that's the background of where it came from. And by now, I appreciate MongoDB. By the end of 2011, MongoDB Inc. started to sponsor the project as well, so I appreciate it. And most of it was written, the bulk of the project was written over a week in Christmas of 2010, and then started to be used at Canonical eventually and by people in the wild. So I want to spend some time then just showing you guys. A lot of people, like the interface, so it's going to be a lightweight talk. I just want to show you guys how to basic start working on it, so that you can then. It makes sense as well because this is the first Go conference, so I wanted to start from the basic, from the bare bones. So when you connect with Mango, you dial, which is a usual name for a connecting method in Go, and you use that same interface, which is very straightforward, as it should be, right? Whether you're connecting to a single server, whether you're connecting to a replica set, or if you're connecting to a sharded deployment with several machines, and this is the exact same thing. The driver behind the scenes will be trying to figure out what's the actual servers that are part of that deployment, and if there's a failover, it's going to do the failover. It will error out to let you know that your actual statement has failed, but it will try again, block until you can do. So all of those things are abstracted behind a simple interface. When you dial, you get back a session, which is basically a handle to the connection pool with a few settings associated with it, but it's something really simple. And if you think about a session, you can think about it as it's not something heavy. It's not something that's has to establish a new connection every time. You can actually, and that's why the interface was designed around the concept of copying. You could use a single session universally, but the way you usually do that, for example, in an HTTP handler, is you copy the session so that you have the same settings but with a fresh environment, and that session is going to have a connection assigned to it, and so that every single HTTP request may be handled in parallel with a different underlying connection. So, and there's a single management Go routine running in the background, doing all those tasks I was talking about to observe whether the server is up, whether the master, the primary, has changed, whether whether you have slaves to talk to, depending on the mode you want to connect. You can talk to the slaves to read data, not from the master, but from someone that has a better load at the moment, for example. So how to use those sessions? The basic idea is you take a collection, which is analogous to a table, has a similar set, similar looking records within it, and you try to find one object, for example. And the interesting thing to notice here is try to link with what Steve was just saying, and with what I was just saying about not having ORM. Those are normal Go values, right? The project type can be as simple as that. It has certain tags which are usual. If you have used the JSON, my apologies. If you have used the JSON package, you recognize those tags, those field tags. This is just setting the field name that should be serialized, and this, if in case it's empty, you don't serialize that one. So what we're doing here is we're trying to find a project with that name, and then we load it in the actual value. And nothing was found because the database has nothing. So how do we insert something? Again, very straightforward. This is like normal Go, right? It's a list of Go values, and then you just tell the database, hey, persist my value. If we run that again, it's just going to say, okay, I did it. And if we go back, we can now find the value.
So one important thing here is we dropped everything before we ran those slides. So this started off with nothing. There's been no structure that we've set up. We literally created Go structures, transformed them to BSON, which the driver does automatically, and persisted them, and that's everything we've done. No setup at all.
So something interesting to notice here is that those types are all equal for the driver after being marshaled. So the same way we've been using a structure, we could use a map, right? Because in some cases, it's convenient to be able to have a map. Or a document slice. Why do we have a document slice? Because, in some cases, it may be slightly more lightweight. A map is a hash map. There's some overhead that has to happen for it to be managed. So there's a simpler way to do that as well if you want to just declare a document quickly. And mixing them is fine. In many cases, you're going to have a project type which has a field which is a map because it's dynamic. You want to be able to assign certain properties that may change depending on the person. Some metadata, for example, that is flexible depending on the project that you guys are using. But I'm sorry. But again, those are all Go values. They're all standard Go values, and again, we can iterate here using a standard Go convention. You probably have seen that next convention in other packages as well. We use something slightly different. We use the actual value in the loop in the next call, but the idea is the same. For every value, every result you get, you're going to have a new iteration of the loop. And then when you leave the loop, you should check the error to make sure that the iteration through the end was all correct. So to update something, we can use an operator, which is, in many cases, there are many operations that are atomic within MongoDB that you can use from Go as well. And in that example, I've declared a local type just for convenience. Just so imagine that you had, for example, many nested maps that you wanted to declare once. You can do that. The driver accepts any subtypes, any types with underlying maps or slices or sorry, my throat is really dry.
So an interesting property of what this is doing is this dollar set operation is one of about a dozen different atomic operations. What this will do is just change that single key within the document. So the rest of the document will persist and stay the exact same way it is. It won't be touched. It's an in-place document update. So it's unlike some other databases that append. This one is very efficient in that it only reaches into the BSON and changes that one value.
Right, and it's an example as well of what I was just describing. Here I'm mixing a map with a structure, and that's all fine. I provide both what I want to update and how I want to update it. So in that case, I'm updating it to v1, for example. I had v0 in my previous slide. If we go back and run it, we have v0 here. If I run that, it updates it. And then we run it again. And so far we've been talking about just flat data, but again, one of the points about that is that we can, with the same kind of convenience, we can have, for example, a nested map. So we have a map here with a normal type. And I'm using a BSON M, which is just the same thing as that, but but it's a shorthand so that it's easy to and convenient to use whenever you're using BSON.
So on this slide, one thing that I've always thought was interesting, when I first discovered MongoDB 5-6 years ago, one thing I always struggled with coming from a relational database background, which was really the only database background that anyone could come from, was that I understand the practical reasons why, but I always felt it was odd that you had to make a join to another table just to have a field that had multiple values in it, or do something weird with some serialization blob storing in there. But it's in MongoDB. That's just a first-class citizen. It has full support for it. So you see here we've got tags. Tags is just like any other field, but this one happens to contain a slice or an array of values.
And if you index that, you can actually look for tags, despite the fact that it's an array.
It'll index every single value and treat it all uniquely. It's a really powerful tool in MongoDB. So let's run this.
Yeah.
And it inserted what we were looking for.
And now we can load it back. But instead of loading in a dynamic map, we're going to load it in a structure.
So one interesting thing, if you haven't used, we've highlighted a little bit of Keith, and your last name I want to pronounce as Rarik, but I have no idea if that's how you pronounce it. But we're using his Pretty Print tool. If you haven't used that yet, it's just really convenient. You should be using Pretty Print because it makes things look pretty, and that's nice.
And just to give you an idea that there's an actual database in the background, even though we can use nested fields, you have all the convenience of the database for the full document, including the nested fields or the nested documents. We could index both a top level or a sub-document, and you can do finds and everything with the same ease. And it's interesting as well because so far, everything I've shown you guys, you could probably have done that with in 100 lines of Go in a disk without any difficulty, right? But it's interesting to notice that there's a whole database behind it with many of the features you expect. So indexing can be done with compound keys, so you have multiple keys. There's list indexing, as we just demonstrated with tags, geospatial things, and so on.
All right. So far, you noticed we started with nothing. We haven't set up anything. And this is a common thing that people think about MongoDB. So it has the notion that it's schemaless. It's the wild, wild west. You can store anything you want. And that notion is somewhat earned because it's true, and we've just proved it. That's what we've been doing. And this is a great feature when you're bootstrapping. So when you're starting a new project, you often don't know what the structures of the data look like, and you want to be able to iterate quickly and change them as you go without having to mess around with them. And MongoDB is great for that. But it's also not the only way it operates, and really it's generally not the best way to use MongoDB. And so one of the great things that Go can bring to this is that because Go provides static typing and reflection, it's able to provide the schema in your application and do so with a good amount of security and make you feel that it's consistent. You don't have to do it again in the database. So when you're working with this pair of MongoDB and Go, you only have to define your schema in one place. You don't have to worry about keeping your schema in your database in sync with your schema in your application. You define it in one single place, which is in your strictly typed Go application. And because the database can still continue to be flexible, but your Go application can provide the structure, it gives you the benefit of being able to evolve your schemas over time. And really, even when you have it right, business requirements change, you're going to need to make modifications. It's great that we can make them in a single place here in the application. It'll work with it in the database, and so we have the benefit of both being the rigidity that the Go structs provide, as well as the flexibility of the database. So we really have the best of both worlds going here.
So let's talk a little bit about concurrency. Whenever I design extensions or packages for Go, one of the things I always try to keep in mind is that I really appreciate the features, the concurrency features that Go provides. And it would be nice if those packages and extensions did not hinder those features, right? Did not get on the way of those features. So this is true with the KML package. There are a number of things there. And this is true with the Mango driver as well. So, for example, in that example I'm providing here, I provided a project's parameter to the f function, and then a name of a project I want to look for, and a done channel just to signal when things are done. And then we do the same thing I did before, just finding one object. And then we execute that twice, once for the KML package, once for the Go check package. And let's see how that works. It just works, right? So if we think about what's going on behind the scenes, that would be one way to implement it, right? I could basically still look like something that is concurrent, but I have a lock, acquire a lock. When you try the first one that tries to define stops, blocks, and waits until it's done. And then the second one is allowed to do. And that's how a lot of drivers implement that logic. But there's a small detail, right? You're basically sitting locally while a whole round trip to the database happens, and database computes the query, runs it, comes back with results, you marshal it, and just so the next one can go. So
this would have the appearance of concurrency, but actually all the behavior of serialization, serialized execution.
Right. So how about doing it concurrently instead? That's how the Mango driver works. It allows you to do the finds and all of the queries that are executed right away. And then it waits until its turn, or until the database has the chance to return results. And it's turn to continue the execution. And all of that happens internally, transparently. You don't have to worry about that. The interface looks exactly the same. One of the interesting sorry, I misordered something. So one interesting thing about that is as I demonstrated before with sessions, you can just have a copy the session and use that in the HTTP handler. That's a nice way to do it because queries are going to be executed concurrently against the database, and they can happen in separate connections. But a lot of people don't realize that they can do that, and they end up just using a global session, which works. But you're only using one single connection to the database, and although they're serialized in certain cases, if the database takes a long time to answer, the next query will have to wait until the database is handling that query. People don't notice the change because of the way that concurrency is implemented. And another area that benefits from concurrency as well is loading. You can just set the size of the batch you want from the database, and then you can tell the driver, when you reach that percentage of objects, please ask for the next batch. And the iteration happens in exactly the same way, but behind the scenes, in background, it's asking for more objects so that by the time you reach that point, the objects are already available in memory.
Okay, so as Gustavo talked about earlier, one of the great features of the dial method is that it doesn't matter what's behind it. You can have a single node, a replica set, which is analogous to just a like SQL replication, but with a little more intelligence around it. It has some automation of failover surrounding it, or a sharded cluster, and all these shards would be made up of different replica sets. So same interface, same application, connecting to different infrastructures, which allow you to grow over time. In fact, you can even go from a single shard or single replica set to a fully sharded cluster without rebooting your application. So it's a really powerful way to scale as you go. And one of the features I want to talk about, there's a lot of features of MongoDB, but one I want to pay particular note about is called GridFS. So GridFS is, first of all, it's even though it has the word file system, it's not a real file system. It's not even actually a property of MongoDB. It's a convention that all of the drivers have implemented. And what it is it's a way to store files properly chunked alongside your MongoDB application data. And it takes advantage of all the different infrastructure pieces that MongoDB provides. So you can save your data and have it fully replicated. You can save your data and have it chunked and distributed across many different shards, which gives you the ability to, you could save very large amounts of data, and it will automatically chunk them, distribute them, write them all concurrently, and then be able to retrieve them all concurrently. So you can get really high throughput when you're using GridFS. So if you don't understand any of that, just think of it more like S3, but that you can control and you can own on your side in your own infrastructure. And MongoDB has a lot more. So there's other things that we haven't talked about and we won't talk about in the time that we have. But Gustavo's written we'll call it experimental, but it's a way to do client-side transactions in the Mango driver. Bill Kennedy, who's going to speak to you later, is going to go into more depth about the aggregation framework and how he's been able to use that to solve a business solution. There's also full-text search, geospatial support, and support for Hadoop, and a lot more features. So there's really quite a rich feature set that might fit what you need. So Confucius is known, one of his quotes is, "I hear and I forget, I see and I remember, and I do and I understand." We're all having fun here today. I want you to be able to not only enjoy your time, but I want you to be able to understand. So take something away from us. And so to understand MongoDB, there's 4 easy steps. 1 is to install MongoDB. 2 is to go get the Mango driver. And then start with something small and get your feet wet. There's a ton of great documentation on the MongoDB.org site. There's great support channels, IRC, Stack Overflow, and we're more than willing to help. And then go out and build something great and open source it and share it with all of us, and so we can all learn. And that's it. Thank you.
We have time for just a few questions.
At the risk of taking it slightly off topic, at the end there you mentioned that MongoDB has some kind of support for Hadoop, and I'm curious what exactly that means.
Yeah, so MongoDB has a connector to Hadoop that lets it be the data source for the Hadoop MapReduce jobs. It also, so it works with it so it can be the input to Hadoop or the output to Hadoop for working with the MongoDB jobs. We're doing a lot of work with the Hadoop community. A lot of people want all the features that a full-fledged database can provide, as well as the data processing that Hadoop can provide. So it's a natural pairing between the two. And it's an open source project called MongoDB Connector on the GitHub page. And you can find more information about there.
So you talked about the notion of application-side schemas. Where would somebody start in terms of versioning schemas? What are some good practices as far as that goes?
Excellent question. When you're doing, so MongoDB doesn't contain it in itself support for versioning schemas. It's really kind of it takes a lot of the same actually fundamental principles as Go does, that it gives you a kind of fundamental platform and lets you build on top of that. So a lot of people have done versioning schemas. I would do that on the client side. There's a lot of different ways of doing that. One way is to contain different structs, orders of your map. Another one is to contain different versions of your struct as you go through. But this would all be implemented on the client side. Another thing a lot of people do is they there's 2 kinds of versioning. One is that the data changes, and one is that the structure changes. So when the data changes, that's the easy one, and that's one that a lot of people build classes and methods around to handle it for them automatically. But it's a very common pattern that people use with MongoDB. Hopefully that answered what you're looking for. You're nodding. Okay, good. Anyone else? So we have one right here.
Yeah, hi there. A lot of ideas going around, a lot of opinions going around that Mongo's struggling to scale, even though that's what it was built for. Is that like a religious thing, or is that a real problem? And how would you respond to people that think things like Cassandra or the other options are the other way to go?
Yeah, it's an interesting thing, and that's kind of a bit of a challenging question, but I'd like to answer it head on. We don't struggle to scale. Some people do struggle to scale with MongoDB, and there's been some, one of the things of having more installations than any other of the newer databases means that there's more people doing stupid things.
Do you have an example? Than
anyone else.
Yeah.
And so when someone makes a mistake with MongoDB, sometimes they'll write a blog post about it, you're going to hear about those more commonly.
And you can cite a use case as well.
So we have many, many, many 1,000-node installations across hundreds of different companies. I'm not making those numbers up. That's legitimate numbers. A few big ones that people have talked about. Disney has 1,000-node clusters. MetLife recently deployed all of their so if you don't know, MetLife is an insurance company in the United States, but they actually own about 90 different brands. So you likely have MetLife insurance, even if you don't know it. And they just deployed all of their user data, all of their insurance information on MongoDB after a 10-year project to do it in a relational database failed. So there's hundreds of huge scaling ones. Pay attention to, just because some people have made mistakes and struggled. And not to say that we're a perfect database, we do have issues, but scaling is actually one of the things we do quite well. And as long as you don't wait until you're fully saturated to try and add more capacity, you're going to do quite well. You're going to really scale well with MongoDB.
More for on the Go side of things, Gustavo, was it you who primarily designed the database SQL API, or the MGO API, and where did you draw that inspiration from, and what in database SQL would you like to see changed, or what should database SQL learn from what you've designed?
Okay, so I honestly, I investigated a lot of ORMs before starting Storm. There's some ideas of Storm in the Mango interface, but it's also very different because Python is a completely different language with different features, and there are many things that cannot be done. But some inspiration from there. But being very honest, I read a lot of code before that, so it's hard for me to say that's where I got from. ORMs are all around, right? I had to design something, so I had to read a lot of code before doing that. And so it was not, I was not looking at the code to do something equivalent, but there's background coming from that side of things. Sorry, and your second question was?
On the SQL side. So I wanted to answer a little bit. One thing is that the Mango driver started open source. We didn't inject. Started off as a community project, not one that's sponsored by 10gen. Evolved to that. But it followed the same conventions as all the other drivers. So the interface is very similar to the Java driver and the C# driver, etc. Although, like all those drivers, we made it idiomatic.
Yeah,
right?
That's not entirely true because, I mean, the design that comes from we have in Mango today, again, was designed around 2010, right? I think it's fair to say that a lot of the design that came over, all of the other drivers were recently refactored.
And it's inspired some of them. That's true.
Right. So it's actually the opposite, right? They were inspired by a lot of things that came into the driver. And answering your second question, it's hard for me to say. Honestly, I don't use it heavily for anything. So it's as an outsider providing suggestions, I don't think it would be valuable. Thank you.